Question number 3 of the worksheet. Force as vector quantity. Okay, so the question is that coplanar forces of magnitude 250 newtons, 100 newtons, and 300 newtons. So the one missing in the figure is 250 newtons. This is the 250 newtons force. Okay. Act at a point in the directions shown in the diagram. The resultant of the three forces has a magnitude of r newtons and acts at an angle of alpha anti-clockwise from the force of magnitude 100 newtons. Find r in it. So there's a resultant force which would be in this direction. And we have to find the value of r, and they're telling you that the angle alpha it makes is anti-clockwise from A, so it's here. Now we need to find R and we need to find A. We know that R is found through Rx and Ry. Once you have Rx and Ry, you apply Pythagoras theorem on it and you get Y. Sorry, you get R. Now, how do we find Rx? How do we find Ry? We will have to resolve these forces into its component. 100 Newton is a horizontal force. It doesn't need to be resolved into horizontal and vertical component. It is already a horizontal component. This one does not need to be resolved into horizontal and vertical component because it is already a vertical component. Okay. This force, however, will be resolved into its two component, this one and this one. And the vertical one I'm drawing here instead. Okay. So there's a 250 Newton force. There's a 70-degree angle. And this is our complete right angle. Okay. So the opposite force or the opposite component is going to be the sine component. So 250 sine 70. So this one is 250 sine 70, which I'm writing here. 250 sine 70. This one is adjacent, so it's going to be the cos component. That's 250 cos 70. Okay. Now Rx is forward force in x direction minus backward force in x direction. So Rx is just 250 cos 70, and there's no backward force in the horizontal direction, so it's going to be 0. For Ry, it's going to be 300 Newton minus, which is the forward force, minus the downward force, which was 250 sine 70. So 250 sine 70. Now we're going to find R by applying Pythagoras on this. So 250 cos 70 whole square plus 300 minus 250 sine 70 whole square. Oh, sorry, there was another horizontal force that I've missed. There was also this 100 Newton force. So plus 100. And here also we're going to do plus 100 in the same bracket. Okay. So when you enter all of this in the calculator, you'll get R equals 196.5886, which rounds off to 197 newtons in three significant figures. Next, we need to find alpha. So for that, we're going to use, this is going to be alpha. So tan alpha equals y component over x component. So alpha is equals to tan inverse. We already have the y component 300 minus 250 sine 70 upon the x component was 250 cos 70 plus 100. You may enter this all together and get alpha equals 19.3 degrees. Yes, Aisha, what were you doing differently?
बस मैंने 300 में ऐड किया होता और
Okay,
सब्ट्रैक्ट मतलब
okay. Forward force in y direction minus backward force in y direction. So 300 minus the opposite force. Okay, moving on. Question number 4. Three coplanar forces act at a point. The magnitudes of the forces are 5, 7, 6, and 7 newtons, and the direction in which the forces act are shown in the diagram. Find the magnitude and the direction of the three resultant forces. Direction of the resultant of the three forces. Okay. So because of the three forces, there's going to be one resultant force. Okay. So we have to find the value of R and the direction. Direction means you have to find the angle and also which direction is that angle in. You also have to indicate that. Okay, so again for R, we need the x component of R, square that, the y component of R, square that, and then take square. I'm not sure where R is going to be. I'm just guessing maybe it's here. The resultant of the three forces we see here, but I'm not going to draw it right now. Okay, so Rx will be the difference of the forces in x direction, forward x force minus backward x force. So I'm going to resolve 6 newtons and 5 newtons into its component. So for 6 newtons, this one, this is the horizontal component and this is the vertical component. The horizontal component is the adjacent component. So it's going to be the cos component, 6 cos 30. And the opposite one I'm drawing here instead, which is the sine component. So 6 sine 30. Similarly, for 5 newtons, we have this component and this component. The second component, which is the opposite component, the vertical one, I'm going to draw here. So that's going to be 5 sine 50. And this one is going to be 5 cos 50. All right. Now, forward force in the R direction is going to be, let me see, Rx. So forward in X direction minus backward in X direction. Forward force is always positive force. I mean, your Rx should come out to be a positive value. So what should I subtract from what? Should I write this first and subtract with this? Or should I write 6 cos 30 first and subtract from the sum of 7 and 5 cos 50? I'm slightly unsure. So what I'll do, I'll just guess and use 7 and 5 cos 50 as my forward forces. 7 plus 5 cos 50 and minus 6 cos 30. So I'm actually saying then that the resultant force is in this direction there. If I'm saying that that's Rx, that's the direction of Rx because I'm taking the right forces first and then subtracting it from left force. But if this answer of mine comes out to be negative, that means Rx is actually in this direction. And I was wrong to take 7 and 5 cos 50 first and 6 cos 30 later. So you can use any forward direction minus any backward direction. If your answer is positive, good. Otherwise, that means the actual Rx was in the opposite direction if your answer comes out to be negative. So it doesn't really matter what you're taking first. Okay, let me check if it's positive 7 plus, okay, this should be in degrees. 7 plus 5 cos 50 minus 6 cos 30. It is a positive value. It comes out to be 5.01778. So yes, that means Rx is in the right direction, towards the right. Okay. For Ry, I have to do up minus down or maybe down minus up. I'm going to take up first and see if I get a positive answer or a negative answer. So 5 sine 50 minus 6 sine 30. 5 sine 50 minus 6 sine 30 is also positive. 0.83022. So that means Ry is an up force. So resultant is somewhere over here. So I was wrong to assume that resultant is there. Resultant actually right here. Okay. That's Ry. Okay. Now we can find R from Pythagoras. Square root 5.01778 square plus 0.83022 square equals anybody has the answer? It says it should be 5.086. 5.086 newtons. Let me check quickly. Square root 5.01778 square plus
5.08599 R.
Okay, let me see. 5.08599. So yes, when you round it off, you get 5.086. Okay. Or 5.09 in 3 significant figures. Okay, now we need to find this theta because we need to give the direction. So theta is tan inverse ry over rx. Theta equals tan inverse ry came out to be 0.83022 and rx came out to be 5.01778, which gives 9.4 degrees. But you're not just supposed to tell the angle, you also have to tell the entire direction. So it is 9.4 degrees above the 7 Newton force. So the direction is 9.4 degrees above 7 Newton force. Or you can say anti-clockwise from the 7 Newton force. If you have questions, please ask now. Okay, question 5 is not a question on resultant forces. I'm skipping it for now. It's actually from the previous topic. Question 6, correct. Two forces, each of magnitude 8 Newton, act at a point in the direction OA at OB. Just give me a second. The angle between the forces is theta degree. The resultant of the two forces has component 8 Newton in OA direction. Okay, so two forces are acting on a point O. That means there's going to be a resultant force here, which is going to be R. I can tell it's going to be in this direction. In every question, it's not that obvious, but in this question, it's pretty obvious. It's going to be somewhere here in this direction. That is, if this was a particle, it would have moved in somewhere in this direction along the green path. Okay, so that's the resultant force. And you're told that the component in OA direction of the resultant force is 9 Newton. That means you're given Rx. That's R, and that's going to be Rx, which is given. Find theta. Okay, so we don't need to resolve this force because it's already a horizontal force. However, we need to resolve this force, which will have two components in this direction and in this direction. The vertical one is opposite to theta. That means it's going to be the sine component. I'm drawing it here, parallel to the original line. It's going to be 8 sine theta. And the horizontal component is going to be 8 cos theta. Okay, so Rx is equals to 8 plus 8 cos theta, and there's no horizontal component in this direction, so it's going to be 0 minus 0, and this is equals to 9. So 8 plus 8 cos theta equals 9. So 8 cos theta equals 1. So cos theta equals 1 by 8. So cos inverse 1 by 8 should give you theta 82.81. Let me check the answer. Yes, that is correct. So theta comes out to be 82.8192. Okay. Find the magnitude of the resultant of the two forces. Okay. So that means we need Ry, and then we're going to apply Pythagoras on Rx and Ry. So Ry is going to be, this is the direction of Ry. So up, forward Ry is the upward facing Ry, which is 8 sine theta. And backward backward y component is going to be the downward component, but there's no downward component in this question, so it's just 0. That makes Ry 8 sine 82.8192. So 8 times sine answer. That is 7.93725. So R is going to be square root of Rx is already known 9 plus 7.93725 squared and 9 squared, which gives square root 9 squared plus answer squared. I get 12 exactly, which is correct. If you're not careful about premature rounding, you might get a different answer. Like you might get 11.82 or whatever. You should get an exact 12 or something that rounds off to 12. And you only get that when you use these longer values in the next step. And in the calculator, you should use the answer key so that it uses all the decimal places. Quick question here.
No, ma'am.
Okay. Question 7. Forces of magnitude P Newton and 25 Newton act at a right angle to each other. So there's a P Newton force and a 25 Newton force mentioned in the question. And mentioned that there's a 90-degree angle. Okay, we can see that in the figure. The resultant of the two forces has a magnitude of R Newton. They've actually drawn the resultant for us in the question. That's actually more convenient. And make an angle of theta degree with the x-axis. That's also shown in the question. The force of magnitude P Newton has a component of minus 2.8 Newton and 9.6 Newtons. Now, what is the meaning of this minus 9.8? That's in the x direction. So it's minus because it's supposed to be pointing towards the left. but you're going to ignore the minus and you're going to point it towards the left, which shows that it's negative since it's a vector, and just take the magnitude 2.8. Okay. Then 9.6 Newton is the vertical component of the P Newton force, which I'm going to instead draw here. So this is 9.6 Newtons. And it makes it an angle of alpha degree with the negative x-axis shown in the figure. We have to find the value of P and the value of R. All right. Now for P, you already have its vertical component, its horizontal component. So just apply Pythagoras on that. P equals square root of 2.8 squared plus 9.6 squared, which gives exactly 10 newtons. Next, we will have to find R. Okay, so for R, you need its vertical component and its horizontal component. So if this is R, then this could be its horizontal component and this could be its vertical component, Rx and Ry. Horizontal component and vertical component always have a 90-degree angle between them. That's how we know that it is the Rx and Ry. However, if you look in this particular question, if you bring this P Newton force to the left over here, you'll still get a right angle here. So you can also find R by using these two forces because this also counts as the horizontal force and this counts as the vertical force because there's a 90-degree angle between them. So R can be found using 25 Newton as the horizontal force and P Newton, which is 10 Newton as the vertical force, since there's a 90-degree angle between them. So R is going to be square root 10 square plus 25 square, which is 26.9. Okay. So we found P and we found R. Find the value of alpha and hence find the components of the force of the magnitude 25 Newton in the x direction and in the y direction. Okay, first we've been asked to find alpha. Alpha is formed between P and the horizontal. And for P, we know its vertical component, which was 9.6, and its horizontal component, which was 2.8 pointing leftwards. So then P is Acha, we did already find P. Sorry, we have to find alpha. So tan alpha equals 9.6 over 2.8, which gives alpha equals tan inverse of this, which is 73.739. 73.7. That's alpha. Okay. And hence find the component of the 25 Newton force in the x direction and in the y direction. All right, so we have A now, 73.7. Okay, this came out to be 73.739. Which question was this? Question 7. Yeah, there is theta, which is 73.739. Okay, so now we need the x and the y component of 25 Newton force. Okay, here's the 25 Newton force. Here is its x component, and here is its y component. Okay, now the problem is we don't have this angle. I'm calling it x. If we find this component out or this angle out, then we can use 25 cos x and 25 by 25 sine x to get the vertical component and the horizontal component. But the question is, how do we find this x? We already know what alpha is. That is 73.739. Then there's a right angle over here. In fact, the right angle triangle ends just before x because theta is somewhere over here. So x is going to be 180 minus 90 minus 73.739. Which comes out to be 180 minus 90 minus 73.739 gives me 16.261. So this small angle is 16.261. Now I'm going to use the vertical component and the horizontal component. Okay. So the horizontal component is going to be, since that's the base, so 25 cos x, which is 25 cos 16.261, which gives 24 newtons. Now we need the y component of 25 Newton force. That is going to be the adjacent component. So 25 sorry, it's going to be the opposite component. So 25 sine 16.261, which is 7 Newton. So we have the answer for 2A and 2B. 24 newtons and 7 newtons. Now it says find the value of theta. Okay. How do we do that? We need theta. We have a few angles here. Let's see if we can make use of that. So theta is this entire angle. Okay. Did we find the theta for R, the resultant force? No, we did not. I think we need to now. Let's find this angle first. Let's call it Y. And then theta is going to be X plus Y. Okay. So that angle Y is actually this angle. This is Y. Let's find it out. Y equals tan inverse 10 by 25. That is 21.8014. So the entire theta is going to be the addition of this with 16.261. The answer comes out to be, when you add these two angles for the last part, you get doing that here. So it's going to be for part 3, 21.8014 plus 16.261, which gives 38.0624, which is 38.1. Okay. I'm going to end this here and give you the next two questions as homework. Okay, now we're going to discuss the pure paper.